Introduction to the idea of functions in mathematics, which is a very crucial topic and is used over and over and over again in many other classes. If you don't get the basics of functions down, it's just going to cause more and more trouble in the future. So the official definition of a function is a rule that assigns a unique, and this is important, unique value of y for every value of x input. So the idea is that you have this input or number or whatever it may be as input, which we usually call x. This is also called the independent variable. And then we will apply some rule and get some sort of an output here, which we usually use the letter y for that. And that will be the dependent variable. And then the rule is that we need to be able to get a unique output for every input. So let's suppose that we are the IRS here. We're going to look at a real-world example of a function. So for the IRS, they need to look at what your income is in order to decide how much money in taxes you're going to be paying that year. Now, if when you filed your taxes, if your input was your name and your output was your income, this would not work as a function. And the reason why is there are people out there that have the exact same name. And if I want to restrict this even further to make it more believable, let's just stick with first name. There are a lot of people named Mike. And if you said every person named Mike, look at your income for that, you are going to get multiple different incomes for different people, even though they're all called Mike. So you would have different outputs for the same income, for the same input, the same name. And as a result, then the IRS wouldn't know about how much to tax individuals. So this is why, one of the reasons why everyone has a unique number, social security number. And so that way that when they do this relationship here, each person will have their own social security number. That means there's never any conflict over having different incomes for the same input. I mean, again, we're not really going to be dealing with that specific type of function in our class. Most functions we have are just going to be formulas involving x, and just regular numbers. But it's still the idea of function is all over in both mathematics and other fields. Again, the importance is that whenever you have an input, you need to be able to have a unique output for that input. That's what makes it to be a function. Now, I made a little comment here that said that some equations are going to give a function and some equations will not. And I gave you two examples here. The first one is that y is equal to 3x minus 1. So then let's think about it. If I pick a number for x, let's say x is 5, and I plug it in, then when I solve for y here, I get exactly one y value. So that means that for every input x, there is exactly one unique output y based on x, and that means this is going to be a function. So this is a function. However, if I look at part B here, it says y squared equals x plus 3. If I chose to plug in, let's say x is 1 here, I would get y squared is 4. And the thing is that there are two possible values for y here, either positive 2 or negative 2, and we don't know which one is the correct answer. And so as a result, that means it cannot be a function because you have two different outputs for a single input. So this one would be not a function. Now it turns out that if you have a graph, a picture, it's really easy to determine whether it is a function or not. And that's going to be something called the vertical line test. And so how is that going to work? The idea is if you have some sort of a graph here, and if you were to go ahead and draw vertical lines anywhere you want, if that vertical line never crosses your graph more than once, then this is going to be a function. Is a function. Whereas if you have a graph and you can draw even a single vertical line that crosses it more than one time, that means it's going to be not a function. So the vertical line test gives us a nice quick way to determine whether a graph is a function or not, just by going ahead and drawing vertical lines. Okay. Now once we have an idea of what a function is, there is some terminology that we're going to need as part of that. And the first of which is actually an incredibly important one, is called the domain of a function. And so what the domain of a function is it is all the possible inputs you can have on your function. So some functions, only certain inputs are allowed and certain inputs will not work. And if we look at all the ones that do work, that's called the domain. On the other hand, if we look at all the possible outputs for a function, that is not called the domain, that is called the range. So usually we're interested in both the domain and the range for a function, and that means we're going to look at what are the possible inputs and what are the possible outputs. It turns out that finding domain, there are going to be certain rules to help you do that depending on what, I guess you should say, formulas or what, different mathematical operations exist in your function there. So we're going to learn different techniques, and in this first video, or first couple of videos here, we're going to see a couple of the techniques for finding the domain, but there are in fact quite a bit more techniques out there for other functions, and we'll learn those in the future. I will say though that a lot of the time there is not a great way to find the range of a function without actually looking at a graph of it. So we're going to learn a lot of nice tricks for domain, but range is going to be a little bit trickier to find. Before we can get into that though, we need to talk about how we can actually do manipulations with functions. So we see here that I gave you a function, f of x is x squared minus x plus 3. And let me go ahead and just explain what that f parentheses x is. And it's read f of x. We use that instead of using the letter y. And one of the reasons we do that is because if you use y, it might have more than one possible value, in which case it's not a function. But if we know it's a function, that means there is only one possible output when you have a given input there. And that's what this notation means. It says this is the output when the input is x. And the thing you're talking about, f, is the name of the function. We almost always use f, sometimes we use g or h, but regardless, that's just the name of the rule that we're talking about. And when we write f parentheses next to it, it means here is the output for this rule. One thing that's really unfortunate is it looks like it's a multiplication there, and it absolutely is not a multiplication. So the whole thing, f parentheses x, it's not a multiplication. It is just a single sentence basically saying this is the output for the rule called f when your input is the number x. So down here I'm saying I want to know what is the output of the rule which we called f when the input is the number 2. So that just means as we use our rule and everywhere we see an x, we put the number 2 into that, and then we get 4 minus 2 plus 3, which should be 5. And so that would be the number that we're looking for here, or you can write it out as f of 2 equals 5. Okay, so we need to be able to, this is called evaluate a function at a given number, and this is how we're going to do it. Also, we're going to be able to combine different functions together using our standard for operations, add, subtract, multiply, and divide. And here's a quick example. My first function, which we call f, is the rule that says x squared minus x plus 3. And my second function, which I'm going to call g, is the rule that says x minus 9. and we're going to combine them. So f plus g, all that's telling you to do is to take both of your functions and add them together. And then you can simplify this a little bit. Minus x plus x cancels out, and then minus 6. So that would be the result of adding the two functions, which we write down as f plus g parentheses x. If I wanted to subtract them, same idea, but now I'm subtracting here. Keep in mind that I'm subtracting the entire rule g, so I got to put that in parentheses and distribute the negative sign in. And then I have minus x is minus 2x, and 3 minus a negative 9 is 3 plus 9 is 12. So that would be the result of f minus g. We can also multiply them. So this is f times g here. So we would go ahead and put down the f function x squared minus x plus 3, then the g function. And you can certainly go ahead and multiply those out and simplify them. I'm not going to bother with it right now. There are times in math where it's better to leave things, separated like this rather than actually working it all out. It just kind of depends on the specific problem, what your goal is. For right now, I will go ahead and leave it like that. And then the last one, division here. We just divide the two formulas we have, and we get this. So this is just a quick overview of some of the basic things you can do in functions. In the next video, we're going to talk more about things like the domain and so on, which is also very crucial with functions.